Don't forget to drink water. Okay, let's continue. Let me check the table of content first. Okay, if I remember correctly, we are in the homework code of chapter 5, the process API. Okay. Okay, in this one, let me open my terminal emulator, and yeah, I kind of this is called kind of curious. I mean, did I already compare this with the debug information? Well, let's compare this again, I guess. It's one. Maybe I should add a breakpoint in here. I mean, I'm kind of curious why there is, what is it called? 3 inferior. Okay, in case anyone knew, no, not that one. And this one, 28. Okay. Oh, right. Okay. And I kind of forgot to set this up. So we are detaching the chat process, something like that. Okay. We are currently in this line. Info inferior. Okay. Now we have two process. Interesting. Oh, wait a minute. If I just use next, continue, okay. Inferior 1, we are in fog. Okay. Next. Wait, what? Hold on a minute. Do we enter the fog first before entering this part. Interesting. Oh, okay. Okay. Inferior. Continue. Exit. So wait, there is 3 process previously. I am still not sure. Right. Inferior. Okay. Yeah, maybe I need to check the previous session for interesting. Here one. Next. You not find bones. Insufficient bug information. We already exit. Interesting. Inferior one. Exit normally. Okay. Anyway, I think let's continue to the second homework. Write a program that opens a file, open system call, and then calls fork to create a new process. Calls fork to create a new process. Can put the child open system call and then calls fork to create a new process. Can put the chat and parent access file descriptor returned by open. Okay, this is the first question. Can put the chat and parent process access the file descriptor returned by open. What happens when they are writing to the file concurrently at the same time? Okay, let's check the first question first. Let me check. I think this one. Okay. Include STTIO. It's STT. Okay. TM. Writing to the file concurrently. So I am assuming we didn't use the wait. produce concurrency in this one. I am not sure. Yeah, we haven't talked about concurrency yet, right? So far, to do that, maybe we can remove the weight PID to make it kind of concurrency. Maybe. Well, let's try this out first. Main phone. See. Okay. Let's see. Okay. And then print apps. Okay, 0. Right. So, do we need to close the standard output? I don't think we need to do that. Okay, so I think we don't need to do this, and can just open, I guess. Return value. X2.txt. Okay. If return value equal -1. Okay, error. Else they print F. Return value. I don't think I need this one. And then, oh, wait. Yeah, I think we need this one to print again. To add, that is it. Can put the child and parent access file descriptor to access the, what is it? The file. So if that is the case, let me add this. Maybe something like this. PIT, get PIT, but then I need to move this. I need to move this before the fork, maybe. Wait. Okay. Let me add a tutu. Not really add. Try open the file after fork. So first, okay, for now let's try opening the file before the fork, and then later on we will try to open the file after the fork and see what happened. Return value, okay. You know what? Maybe I need to do something like this. And this one, oh sorry, this one should be in here. Okay, and then the else for the parent. Oh, not that one. Okay. Oh, wait a minute. Oh, wait, no. I can do something like this. I mean, try without wait. For concurrency, I mean, I'm not sure if we can call that concurrency. For the next question. Concurrency. Okay. Else wait. Okay, and then print this. Oh, wait a minute. Do we need to close the file? I think we need to close the file, right? Maybe something like this. Wait. The file. First, let me try with the setup. With the setup for now. Okay, not that one. Okay. Okay, what is install? Alright. We print out the, what is it called? The chat process PID first. Okay, you know what? Maybe something like this. Chat PID and then parent PID. Okay, now let's compile again. Okay, chat PID and then parent PID. And now I want to try closing the file. What happened? I mean, if I understand correctly, right? If we close the file in here, let me check. If I close the file in here, I'm assuming we cannot access that in the parent after we wait for the child process to finish. That is my hypothesis, which can be wrong, I guess. See? But yeah, let's try that out. On error -1, okay. Close return value. Maybe I should call this FD for the file descriptor. Maybe. Okay. On error -1, okay. Let's say close. If I say close -1, Okay, we have error no to indicate the error. Okay. Close error. Okay. It's true. We didn't get an error. Okay. That is interesting. Are we really closing? The file descriptor to zero on success, negative on error. Okay. Okay. We run this twice. And it didn't cause any problem. Okay, interesting. Wait. Let me check the file descriptor. Are we using the same file descriptor? We are using the same file descriptor. But what is it called? But its process did not affect each other, I guess. I mean, like, if we close the file in the child process, it did not affect the open file in the parent process. Yeah, let me read that. Looks like we close the file in child process. Close the file descriptor. We still have it did not affect the file descriptor open in parent process. Question mark, because I'm not sure if that is correct or not. Okay, that is quite interesting. Which one I should do first? Should I try without wait? Maybe I should try without wait. Let's make it non-deterministic, like a lot of people like this day. Okay. Okay. And then what is it? Okay. But at least we know that we are appending rather than replacing, in cell there is this, what is it called? This double greater sign like this, which means that we can append to the file, right? And also this one, the single greater sign, which is gonna replace the content in the file. See, so it looks like we are appending, or maybe that's because they print F. Let me check. Okay. The same as fprintf, except that it outputs to a file descriptor ft instead of to a standard input-output string. Okay, interesting. Okay, for this one, what happens when they are writing to the file concurrently? I'm still not sure how to do this yet. Can both the child and parent access the file descriptor written by open? For this question, the answer is yes. Okay, wait, let me try this tutorial. Open the file after the fork, not before the fork. Okay, something like this. Compiling. Okay. Oh, interesting. Okay, so there is a difference here. When we open the file before fork and when we open the file after fork. Okay, that is interesting. Chapter install, okay. See? What is happening? I mean, can we like opening the file after the fork? Wait. I think, where is it? Yeah, I think we enter the fork first, right? Before executing anything below this, I'm assuming. Wait, let's try this one. Open the file after the fork, right? And then not wait the chat process. What is it? Only the chat process. Oh, that is interesting. Is it maybe because of this? Let me try. Not really. Interesting. Process. If that's the case, wait. You know what? That make me wonder what happens if we do something like this. Is it maybe like replacing the content instead of appending? You know? Let's find out. Type. Okay. Chapter S2. Okay, parent first and then child. I'm assuming the one getting written is the child. And yeah, the child getting written, but wait, there is extra new line. Okay, let me check. Why is there any extra new line? Is it from this one? So, okay. Yeah, why is there any extra new line? Okay, this is getting interesting. See, there is no new line. So what happened there? Where is the new line came from? I mean, if we do this like, if I do it like this, we will flash in here, right? Because of the new line character. Oh, I forgot what it is called, but it is related to the new line terminator, maybe something like that. Okay, alright, I use ZS8, so in ZS8, if there is no new line terminator or character, ZS8 will use the percentage sign like this. Let me try. It is still there, so what happened? do something like this. Okay. Alright. Okay. And then let's get. Oh, interesting. That is interesting. There is no new line like this one. Or maybe empty line is the right word. Okay, What happened there? Why adding new line in here have anything to do with the file descriptor here? What is the relation of that? That is, see. Should I take a look at GTP? Wait, before that. Let me check this. Oh, okay. I mean, we wait for the chat process to finish, so the parent is on the last one. But yeah. What happened when we do this? Like we didn't wait for the chat process to finish. And why there is new line character or empty line? Let me check why there is empty line in the file. Okay. See, there's empty line. Okay, so can put the chat and parent access the file descriptor written by open. I assume yes. Right, written by open. But the way writing to the file is something that I'm not sure. I mean, I'm using the printf. Maybe we should use something else. Is there any example, maybe? if we close the standard output, is there any effect? Let me try. Oh, where is it? In this one, close STT out file number, okay. I say close if I say close equal negative 1. Error cause error, and then constar. Okay, I thought we can use the format like printf return 1. Okay, something like this. Turtle s2. Okay, and then it's 2.txt. There is still empty line. Interesting. Okay. What is it? C programming write to a file. Maybe I shouldn't use the printf and use, what is it called? Append to the end of a file and use write, maybe. In append mode. Okay. No, not that one. I've put C. A lot of article using fopen. Is that the only way? Let me check. Fopen. Yeah, I'm still not sure what is the difference between fopen and open function. I'm assuming, well, the most obvious one is the return value, I guess. I mean, if open, I think open a system call, okay. It is integer. It is for the file description, a file descriptor number. Yeah, using excuse me, using fopen. something like this. Hello, Talis of Miletus. Wouldn't the two process override each other? That's what I'm not sure. I mean, okay, there is a case where the two process appending to the file. Let me try this one. Where is it? The previous one is, well, let me run this. Okay, right. There is a scenario where the process just appending like this instead of rewriting or overwrite each other. So when we open the file before the fork, it looks like the behavior is like appending. Again, I'm still not sure. This is just assumption at this point. But when we put open after the fork, okay, let me run this. It looks like the behavior is replacing rather than appending instead of this one, right? It's like we are appending to the file, but when we open the file after the fork, what is it called? The process override each other, something like that. So yeah, I'm not really sure if that is correct or not. Okay. That is quite interesting. And now I am not sure why there is a new line. When we do something like this, there is no new line, right? But when we exclude the wait, so we are not waiting for the chat process to finish. See, the last one is the child, right? Instead of like this. And when we check the file, there is empty line after the type PIT. And the interesting part is that when I remove the new line character here, like this, like there is new line character. This is called. Let me run this, become like this, right? The printf, we are printing to the standard output. And then when we check at the file, there is no empty line. So why this new line character matters, Okay, that is quite interesting. Hello Satya, welcome. Okay, for those who are new, we are currently reading this book operating system 3 easy PCs, and currently on the chapter 5, the interlude process API, and we are checking out the homework code section. Where is it? This one, homework code section. So we are writing some code to check things out. Previously we already checked this one, the first question, and now we are checking on the second question. Write a program that opens a file with the open system call and then calls fork to create a new process. Okay, can both the child and parent access the file descriptor returned by open? I'm assuming we can, but yeah. I mean, return by open. There is no specific information when we open the file, right? Oh, sorry. It looks like open a file and then calls fork. So the mechanism in the question, right? And then calls fork. The mechanism is that we are opening the file first before calling fork, before calling this one, other than calling fork first and then open the file, right? Let me try to demonstrate that. Something like this. We open the file first and then we call fork, right? And it will, well, at least in this case, I'm assuming it will append to the file, right? Parent and then child. So if we open the file before fork, this one, the behavior is kind of appending to the file. But when we open the file after the fork, it's like we are overwriting the, what is it called? The file, the content in the file. Okay, I'm still not sure. Okay, so if this is the mechanism for the question, then yeah, the answer for this, can both the child and parent process access the file descriptor returned by open? I think the answer is yes. Can we open first and then call fork? So the child and the parent can access the file descriptor returned by open. What happens when they are writing to the file concurrently? I mean, we haven't talked about concurrency yet at this point. So I am not sure what concurrency in this mean. I mean, I'm assuming that we didn't wait the child process like this. But yeah, I'm not really sure. What happens when they are writing to the file concurrently? Okay. Let me add some explanation. Just because the bot can open the file doesn't mean they should. Yes. Doesn't mean they should. Okay. I mean, yeah, that can be confusing, I guess. Okay, looks like there's a difference between opening the file before fork and after fork. Okay. Still not sure what is the difference. I mean, I'm still guessing, I guess. But yeah, is the behavior correct? Like, it is appending, right? Where is it? This one. When we open file after fork, let me put this like this. After fork, and then where is it? The file after fork, not using wait, and also add new line character in printf below. Okay. Let me try again. Okay, chat first and then parent. So, okay. It is kind of appending. Not replacing. Okay. But yeah, I'm not sure if that assumption is correct or not. Okay. Maybe we will continue this on the next session. So that's it for now. Thank you for watching and see you next time. Bye bye.